Hello, hi everyone. Welcome to the Student in the Brand. This is our Shiva sir. Today topic is light reflection and diffraction chapter. Hello, hi everyone. We'll start. So today we are going to discuss about light reflection and refraction chapter. Light reflection and refraction chapter. Light reflection and refraction chapter. Okay, so in this chapter we are discussing especially reflection of light. Reflection of light. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. So when light incidenting on the surface, so here I am considering reflection of light, reflection of light, reflection of light. So I am taking the plane mirror. So this is a plane mirror. This is a plane mirror. Okay. So this is incident ray, reflected ray, incident ray, reflected ray, and the line which is perpendicular to the plane surface is called normal line. Normal line. So I'm considering here. So like this. So incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. And the line which is deviating through the surface, that is undeviated line. Normally, if the light ray passes in a homogeneous medium, it moves in a straight line path. If the light ray moves in a straight line, if the light ray moving in a homogeneous medium, it moves in a straight line path. It moves in a straight line path, right? Yes. So here, so this undeviated line, undeviated line. The angle between reflected and deviated line is called angle of deviation. Angle of deviation. I hope it is very clear. Check once. Angle of deviation. Angle of deviation. So here you can observe the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Bouncing back of the light from the reflecting surface is called reflection of light. Or so reflecting back from the reflecting surface. Reflection of light from the reflecting surface is called reflection of light. So here if you are taking this angle 180 degrees, linear angle is 180 degrees. Linear angle is 180 degrees. Okay. And so here you can observe angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay, done. Now here, so from loss of reflection, 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 loss of reflection is nothing. First one, incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies in the same plane. Second one is angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Once again, incident ray, reflected ray, normal line lies in the same plane. Okay, incident ray, reflected ray, normal and lies in the same plane. Angle of incidence is equal to angle of reflection. Angle of incident is equal to angle of reflection. So from that, angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. And also we can write angle of angle of deviation equal to 180 minus 2 angle of reflection. 2 angle of reflection. I hope it is very clear to all. Just check once. Okay. So reflection of light is nothing but the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. And so incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. And angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So we know that linear angle is 180 degrees. Linear angle is 180 degrees. Okay. So linear angle is 180 degrees I am taking. Now linear angle is 180 degrees. And the linear angle, and the linear angle, and the linear angle, so you can observe here on the linear angle. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So instead of angle of reflection I am writing angle of incidence. Angle of reflection I am writing angle of incidence. So we can write angle of deviation equal to 180 minus 2 angle of incidence. So we can also write angle of deviation equal to 180 minus 2 angle of reflection. Okay. So this is about reflection of light, loss of reflection and angle of deviation formula. Now we will discuss about image and object. Okay, so image and object. Now you can see here. Now you can observe image and object we are discussing now. So like this. So from this point light rays are coming like this. After reflection those light rays are moving away from it here and here also. So we can extend these light rays. We can extend these light rays like this and here also. So this is the real object and virtual image. Real object and virtual image. From one point if the light rays are coming, from one point if the light rays are coming, so that is a real object. So after reflection we are extending these light rays. After reflection we are extending this reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. So their image is forming. That is a virtual image. Virtual image. Okay, now you can see here. Now, so light rays are coming from object. After reflection, those light rays are meeting at one point. Light rays are coming from the object. After reflection, those light rays are meeting at one point. Those light rays are meeting at one point. So here, this is the virtual real image. This is the real image. So real image. So if you are extending these light rays, the virtual object. So the point of intersection of reflector light rays. The point of intersection of reflector light rays is called real image. The point of intersection of reflector light rays is called real image. the point of intersection of extended incident light rays. Extended incident light rays is called virtual object. Virtual object. So here you can observe the point of intersection of incident light rays is called virtual object. Here the point of intersection of extended reflector light rays. So we are extending this reflector light rays. Extended reflector light rays are meeting at one point. Their image is forming, that is virtual image. Here point of intersection of extended incident light rays. So if you are extending the incident light rays are meeting. So their virtual object is forming. Virtual object. I hope it is very clear, right? Yes. So yes. So real object, virtual image, real image and virtual object. Real object and virtual image, real image and virtual object. Virtual object. Now, so you can observe here. You can observe. So I am taking now like this. So if you observe this entire phenomena, object and image, if you observe entire these two diagrams, we can conclude that object is real, image is virtual. Object is virtual, image is real. Okay, vice versa. If the object is real, image is virtual. If the object is virtual, image is real. Image is real, vice versa. So by concluding these two diagrams, we can say like that. Here from the point incident light rays are coming. So directly incident light rays are coming, that is a real object. Here we are extending the reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming, that is virtual image. Here these are the incident light rays. After reflection, those light rays are meeting at one point. After reflection, those light rays are meeting at one point. Their image is forming. There is a real image. So we are extending the incident light rays. Extended incident light rays are meeting at one point. Their virtual object. So by this, we can conclude that by observing these two diagrams, we can conclude that object is real, image is virtual. Object is virtual, image is real. I hope it is very clear to all. Yes. Now, so we'll go to the nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror will discuss. Nature of the image formed by the plane mirror. Okay, done. Check once here. So I'm taking the plane mirror like this. So this is the object. This object A, B. Okay. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So one light ray I am taking like this. Okay. So here and one more light ray. So here. So if you are extending these light rays, so now you can observe here. So A dash and B dash, AB and A dash, B dash, A dash, B dash. Okay, A dash and B dash. Now you can observe. Object is real, image is virtual. Object is real. Point number 1. Object is real, image is virtual. Object is virtual, image is real. Point number 2. The distance between object to mirror is called object distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. So in plane mirror, object distance is equal to image distance, and the third one, height of the object is equal to height of the image. Height of the object is equal to height of the image. And the fourth one, okay, so magnification of the plane mirror is +1. Magnification of the plane mirror is +1. So m equal to +1. Magnification of the plane mirror is +1. Coming to the fifth one. Okay, so now you can observe here. Magnification of the plane mirror is +1. And the next one, it also shows lateral inversion. Lateral inversion is nothing but lateral inversion is nothing but lateral inversion. Lateral inversion is nothing but, so the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. The phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So this mirror image is called lateral inversion. Once again, lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So this mirror image is called lateral inversion. I hope it is very clear. So this is about nature of the image formed by the plane mirror. If the object is real, image is virtual. If the object is virtual, image real. So point number 1. Point number 2. Object distance is equal to image distance. Point number 2. Point number 3. Size of the object is equal to size of the image. Height of the object is equal to height of the image. And also magnification of the plane mirror is +1. And also it shows lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. This mirror image is called lateral inversion. I hope it is very clear now. So now we will discuss about spherical mirrors. Okay, now, so spherical mirror, the mirror which in the form of curved shape, is called concave spherical mirror. The mirror which in the form of curved shape is called spherical mirror. So the mirror whose reflection takes place inward is called concave mirror. The mirror whose reflection takes place inward, that is called concave mirror. So I am considering here, this is a concave mirror. Reflection takes place inward. So point number 1, and here I am considering like this. So here concave mirror. Concave mirror is also known as converging mirror. And convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror. Now you can observe. So concave mirror is also known as converging mirror. Convex mirror is known as convex mirror. Convex mirror is known as diverging mirror. Diverging mirror. Concave mirror is known as converging mirror. Convex mirror is known as diverging mirror. Okay. So why? Why? Because whenever light rays falls on it, it converges the light rays and meet at whenever light rays are falling, so those light rays are converging and meeting on principal axis here. So whenever light rays are falling, so the light rays are moving away from the principal axis. So here this mirror is called converging mirror because after reflection the light rays are moving towards the principal axis. Here light rays are moving away from the principal axis. That's why it is called diverging mirror. Converging mirror and diverging mirror. Now, so we'll go to the next one. Okay. Now concave mirror. Terms related to concave mirror will discuss. Terms related to concave mirror will discuss. Terms related to concave mirror. So it is a part of the sphere. So the center of the imaginary sphere in which mirror is a part. Okay, my human eye also I will explain. Human eye I will explain after completion of this chapter. Light reflection and diffraction. Human eye I will explain. Okay, don't worry about it. Now here you can see the center of the imaginary sphere in which mirror is a part. The midpoint of the mirror is called pole. Midpoint of the mirror is called pole. So the line joining of central curvature and pole is called the line joining of central curvature and pole is called principal axis. First one is central curvature, second one is pole, third one is principal axis. Principal axis. Principal axis, and fourth one is the distance between central curvature to pole is called radius of curvature. The distance between central curvature to pole is called radius of curvature. And fifth one, after reflection all light rays will meet at one point on the principal axis. After reflection all light rays will meet at one point on the principal axis called focus. And sixth one, the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. So simply we can say focal length. And seventh one is width of the mirror is called aperture. Width of the mirror is called aperture. Okay, so once again, so you can observe the midpoint of the mirror is called pole. The midpoint of the mirror is called pole. Sorry, the midpoint of the mirror is called pole. Center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part. Midpoint of the mirror is called pole. Center of the imaginary sphere in which mirror is a part is called central curvature. The line joining of central curvature and pole is called principal axis. So the distance between central curvature to pole is called radius of curvature. After reflection, all light rays will meet at one point on the principal axis called focus. The distance between focus to pole is called focal length, and width of the mirror is called aperture. So these are the terms related to spherical mirror. Right? Yes. Now we will discuss about ray rules of concave mirror. 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 Ray rules. Ray rules of concave mirror. Ray rules of concave mirror. So point number 1. So pole, focus, center of curvature, pole, focus and center of curvature. So I'm taking one light ray. After reflection it passes through focus. Second one. So pole, focus, center of curvature, light rays passing through focus after reflection, moving towards infinity. Coming to third one. So pole, focus, center of curvature is passing through center of curvature. It retraces its original path. So coming to fourth one. Light ray is incidenting at the pole. This is the pole. Focus, center of curvature, light ray incidenting at the pole. So it reflects back. Okay, so these are the 4 ray rules for concave mirror. Next we will discuss about convex mirror. So convex mirror. This is a concave mirror. Concave mirror. Next, convex mirror. Convex mirror. Convex mirror. So pole, focus, center of curvature. Oh, sorry. This is concave mirror, convex mirror. Concave mirror. This one. So convex mirror. So this is a convex mirror. So pole, focus, center of curvature. Light ray is coming from infinity after reflection. Light ray is coming from infinity after reflection. It moves away from the principal axis. Like this, it passes through focus. Second one. So pole, focus, center of curvature. Light ray is coming from infinity after reflection. It passes through. It moves towards infinity. Light ray is coming from point. So passing through focus after reflection moves towards infinity. Coming to the third one. So here you can see. So pole, focus, center of curvature. Light ray is passing through center of curvature. So it retraces its original path. Means it moves in the same direction. And coming to the fourth one. So this is the pole, focus, center of curvature. Light ray is incident at the pole. So it reflects back into the same medium. So these are the ray rules of concave mirror and convex mirror. So light ray is coming from infinity after reflection. Light ray is coming from infinity after reflection, passes through focus. Light ray passing through focus after reflection moves towards infinity. Light ray passing through center of curvature treats its original path. Here, light ray is coming from infinity after reflection, moving away from the principal axis. Light ray is passing through focus after reflection, it moves towards infinity. Light ray passing through center of curvature, it retraces its original path. Light ray is incidenting at the pole, it reflects back. So these are the ray rules. These are the ray rules of concave mirror and convex mirror. These are the ray rules of concave mirror and convex mirror. So now we will discuss about image formations. Image formations of concave mirror and convex mirror will discuss. Okay. Check once. Okay, now we will discuss about concave mirror image formations. We'll discuss about concave mirror image formations. Concave mirror, concave mirror. Okay, first one. So pole, focus, center of curvature, pole, focus and center of curvature. Light rays are coming from infinity. Light rays are coming from infinity. After reflection, light rays. So object is at infinity. Simply we can say object is at infinity. Object is at infinity. Object is at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required, right? So I'm considering like this. One light ray like this. Another light. So object is at infinity. Image is forming at F. Nature of the image is real and inverted. So size, image size is highly diminished. Coming to the second one. So here I'm taking like this. So this is the pole, focus, center of curvature, pole, focus and center of curvature. Pole, focus and center of curvature. So object is placed beyond center of curvature. Here I am placing the object. How many light rays? Minimum 2 light. One light I am taking like this. So after reflection passes through like this. So another light I am taking like this. It passes. So the image is forming here. Object is placed beyond center of curvature. Beyond C, image is forming between C and F. Nature of the image is real and inverted. And the size of the image is diminished. Compared to the object, image size is decreased. Compared to the object, image size is decreased. So that's why it is called diminished. Diminished. Okay. Next one. Third one. So pole. So this is the pole. Focus. Center of curvature. Pole focus and center of curvature. Object is placed at C. So image also will form at C. Object is placed at C. Image also will form at C. One light ray I am taking like this. It passes through focus. One light ray. So one light ray is passing. Another. So here I am taking. Another light ray incidenting at the pole. See. Okay. So light ray I am like this. Object is at C. Image also will form at C. Nature of the image is real and inverted. Size of the image is same size. Same size. Okay, coming to the fourth one. So this is the pole, focus, center of curvature, Object is placed between C and F. Object is placed so object is placed. So one light I am taking like this. So it passes through focus. Another light ray incidenting at the pole. So after that, object is placed between C and F. Object is placed. Object is placed between C and F. Image is forming beyond center of curvature. Beyond C, nature of the image is real and inverted. Size of the image is enlarged. Here, after same size, whatever the image is coming, it will be enlarged image only. Enlarged image. Next one is fifth one. Okay, so okay, so next one, fifth one. So here I am taking this a pole, focus, center of curvature. Object is placed at focus. So I am placing here. Object is placed at focus. So one light I am taking like this. After that, it passes through focus. Another light ray is incidenting at the pole. It reflects back. So those light rays will meet at infinity. Object is at F. Image is forming at infinity. Object is at F. Image is forming at infinity. Nature of the image is real and inverted, and size of the image is highly enlarged. Okay, so that is the fifth one. Coming to the sixth one. Sixth one is very important. Sixth image formation is very important, because so every time we can see, we can observe in the exam, this question they will ask, surely they will ask. So that much important it is. So here I am considering like this. Pole, this is the pole, focus, center of curvature. Object is placed between F and P. Object is placed between F and P. One light I am taking like this. So after reflection passes through focus. So another light ray is incidenting at the pole. So it reflects back. So if you are extending these light rays, these extended light rays are meeting at one point. So here. Okay, so the image will form here. What type of image will form? Virtual, erect and enlarged. Virtual, erect and enlarged image will form. Virtual, erect and enlarged. Object is placed between F and P. Image is forming behind the mirror. Behind the mirror. Nature of the image is virtual, erect and enlarged. Virtual, erect and enlarged. Only in this case only will get virtual erect and enlarge. What is the nature of the image? Virtual erect and enlarged image will form. Compared to the object, image size is increased. Compared to the object, image size is increased. I hope it is very clear. Okay, so that's enough. So this is about concave mirror image formations. Next one we'll discuss about convex mirror. Convex mirror image formation. Convex mirror image formations we'll discuss. Convex mirror. Convex mirror. So first only two cases are there. Only two cases are there. So pole, focus, central curvature, pole, focus and central curvature. Now, so object is placed at infinity, light rays are coming from infinity after reflection. Those light rays are moving away from it. If you are extending, the image will form. Object is at infinity, image is forming at focus. Nature of the image is virtual erect. Nature of the image is virtual erect and diminished. So in convex mirror, always virtual erect and diminished image only will form. Okay. So virtual erect and highly diminished. Coming to the second one. So this is the pole, focus, central curvature, pole, focus and central curvature. Object is placed anywhere between infinity and pole. One light ray I am taking like this, it will be reflected back. Another light ray I am taking like this, so it moves. So if you are extending these light rays, the image will form here. The image will form between P and F. Object is placed between P and infinity. Image is forming between P and F. Nature of the image is virtual erect and diminished. Virtual erect and diminished. Virtual erect and diminished. So this is about convex mirror. Concave mirror and convex mirror. I hope it is very clear now. So we'll discuss about sign conventions. We'll discuss. Sign conventions. Okay. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. distance are positive. Above the principal axis, distance are negative. Below the principal axis, new Cartesian, new Cartesian, sign convention, new Cartesian, sign convention, all distance measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian, sign convention, new Cartesian, sign convention. So, all measurements we are taking along the incident trace, positive. All measurements must be considered from the pole. All measurement must be considered from the pole. In the direction of incident rays, all are positive. Object distance, image distance, focal length and radius of curvature all are positive. Opposite incident rays, object distance, image distance, focal length and radius of curvature all are negative. Above the principal axis, so height of the object and height of the image is positive. Below the principal axis, height of the image and height of the object both are negative. All measurements will be considered from the pole in the direction of incident is positive. Opposite to incident is negative. Above the principal axis positive. Below the principal axis negative. New Cartesian sign convention. New Cartesian sign convention. All distance are measured from the pole. Distance are positive along the incident rays. Distance are negative opposite to instant rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian, new Cartesian, sign convention, new Cartesian, sign convention. So this is about new Cartesian sign conventions. Along the incident is positive, opposite incident is negative, above the principal axis positive, below the principal axis negative. As we can see, as we can observe the coordinate axis, positive x-axis, positive x-axis, negative x-axis, negative x-axis, positive y-axis, negative y-axis, same thing. Similar, similar, similar. I hope it is very clear to you all. Yes, now, so we'll discuss about okay. So that's enough. That is about concave mirror and convex mirror. Chalo then. So we'll discuss next one. So mirror formula 1 by f equal to 1 by v plus 1 by u. Magnification equal to height of the image by height of the object minus v by u. Okay, so this is about mirrors. So now we will discuss about convex and concave lens. About lens we'll discuss in the next class. So we'll see. Thank you.